We are at question set 3. Question number 5. Are taxes calculated differently by location? Question number 6. Do houses with higher value pay higher taxes? Again, I want you to look at the data set and pause the video and think about these two questions for a bit. So for question number 5, we can use pivot table to group by location and produce some statistics such as average and standard deviation on the column taxes, similar to what we did previously. However, here we are going to try some visualization techniques to see if we can glean more insights about the relationship of location and taxes. The first thing we will try is the line chart. Again, I would duplicate the raw data into a new sheet. And I would renaming it line and sorting so that I don't inadvertently damage the raw data. And again, I'm going to freeze the top row for ease of navigation. We can create a line chart for the column taxes by first select the data range in column taxes and then go to insert, then go to charts and select the 2D line chart. So let's first make sense of this line chart. So if you choose a point and move your cursor, hover your cursor above it, for example this point, it will show you what that point is. So it says point number 10, value 10,753. So if you go to the raw data, if you go to row 11, because remember we have a header, so this is a row 11, but it's actually the point number 10. And then you will find the taxes value at 10,753. So this means line plot simply plots the value of the selected column as the vertical axis against its row numbers. In this case, the row numbers minus one because there's a header row, as the horizontal axis, and connect all the adjacent points together in many line segments. There's one thing that might not be obvious to you until now. In Excel tables, rows do not have an intrinsic order. The reason we see this chaotic ups and downs pattern is because the original row order of houses placed in this table doesn't have any meaning. Further, columns do not have any intrinsic order either. In other words, I can move the whole column and place in a different location. I can move the whole rows and put it in a different location without changing the data set. However, whenever movement you make, you need to make sure that the whole column of a row need to stay together as one unit at all time, because each row represents a house. So if you accidentally only swapping two cells, for example this cell with this cell in one column, you would have damaged the integrity of the data. We can provide meaning to the order of these houses by rearranging them according to a particular column. For example, I can go to data filter, and then I would sort the column taxes in the order of smallest to largest. And you can see the line chart as a result will become an always increasing curve. Now when we rearrange rows, we are moving the whole rows as a unit, not just those cells in the column of taxes we use to sort. Therefore, it's very important when you select filter, you need to make sure all the drop-down button appearing on all columns. Notice once you have done this, the original order in rows is irreversibly lost. So if you are worried that maybe there is some meaning to the original order, then we can create a new column to preserve that order. So let's first undo what we did using sorting. So now we are back to our original order, and let me insert one more column, and I would call it raw order. And I would just need to simply populate this column with the number 1 to 362. You can do this quickly by first enter, say 1, 2, and 3, and then you can select them together and move your cursor to the bottom right. And once the cursor changed to this solid tiny cross, you can just simply double click, and then the Excel would automatically recognize the sequence and populated the whole column, which is what we wanted. In rare cases where you do want to sort just by one column alone, thereby intentionally corrupting the data integrity, you can choose one column, then click filter. Let me first unselect filter, and then I will select just the column and go back to data and click on filter. Notice now only that column you have selected has the drop down button. And let's click on it, and then let me choose sort smallest to largest. Excel would actually provide you a warning. It says that there are data next to your selection. So you can continue this kind of sorting by click on continue with current selection, but again, remember, you would have completely ruined the data integrity. But this kind of manipulation is useful at times when you are creating new columns. So we're not going to do that here. Let's now again sort the data set by taxes ascendingly. And since we are interested in question 5, the effect of location on taxes, so let's also sort by column location. So to use multiple columns to sort, the best way to do so is to go to the drop-down menu, go to sort by color, and then click on custom sort. So we have already put in a taxes as the one level of sorting. Now I'm gonna add another level, which is location. So you might not see a whole lot of difference in terms of the line chart, but if you zoom closer, you will see that now for the same taxes value of 4320 for these houses, the locations are indeed sorted alphabetically from A, B to C's, and you can see that there are no houses in location D and E that has this particular taxes value. But let's go back to reorder the sorting sequence. I'll go back to custom sorting. Now I would actually reverse the orders. I would sort first by location from A to Z, then I would sort by taxes, again ascendingly. So now we see the picture is quite different because our first criterion to sort is the location. So we sort first by location. Look at all these on the top, all these houses are in location A and B and C, so on and so forth. But within the same location, for example, for A, you can see the taxes are sorted ascendingly, as is shown in this chart, this line chart. Sorting rows according to one or multiple columns is another common data manipulation technique. So what can we learn from this sorted line chart? First by location, then by taxes. Quite a bit actually. We can read of min and max for each location, for example. So for the location A, the minimum value is about 2800, for example. And the highest value for location A is this point, close to 12,000. And you can also see how many houses in location A by reading this number. So there are about 75 houses in location A. You can do the same thing for all the other locations. We can also get a sense of average and standard deviation. For example, in location A, since these are the taxes, so the average of location A will be somewhere in the middle, close to 6,000. We can also tell that the standard deviation for location A is a lot larger than, say, location C. Why? Because if, say, for example, if a location has houses of all the same taxes, then this line will become horizontal because they are all the same for a particular location. Therefore, the flatter the line, the smaller the deviation of individual houses to its average. Therefore, the smaller the standard deviation. So therefore, I can infer that this location C should have a lower standard deviation than location A. There are a lot more subtle things that you can tell from this line chart as well. For example, we know that within each location, the taxes go from smallest to largest. So it should increase constantly. But why most of location, they increase in this pattern? They increase in they increase this way. Most of location has this rising patterns. So why not the other way around, like this? So for the sake of time, I'll leave this as a thought experiment for you and see what kind of inference you can make by observing this rising pattern. However, none of these seems to provide any concrete information about question 5. So let's table this for now, and then we'll go to question 6. Question 6 asks, do houses with higher values pay higher taxes? So for understanding the relationship between two numeric columns, in this case value and taxes, the best visualization tool is to do a scatter plot. So here I'm going to again create a duplication of the raw data. and I would rename it to scatter plot. So now I need to select these two columns at one time. So to do that, the shortcuts that I introduced in previous video become fairly important. So what I do now is I would again first select the first column by press down Control Shift and downward arrow. Now I'm going to go back to the top of the data set. So this time I'm going to first press down Control key, and then I will select the first cell of the taxes column, which is the header. Then I will press down Shift key, and then I will hit downward arrow. So by doing these, I can select these two columns that are not next to each other. Of course, if you find this too complicated, you can simply cut the column taxes and move it to the right of values. And then I can now go to Insert and Insert Scatter. Notice by default, Excel places the scatter plot right in the middle of your current worksheet. It will stay there. If you scroll down, it will actually disappear on you if you scroll down to a lower portion of the table. So in order for me to be able to see the scatter plot always, I would insert a few empty cells on the very top, and then I would actually move the scatter plot in this top portion. So now as I scroll down the raw data, the scatter plot itself will stay put. This is also known officially as the Cartesian coordinate system, where the x-axis, the horizontal axis, represents values of each house, and the y-axis, the vertical axis, represents the taxes amount for each house. So let's dwell on this chart for a bit to truly understand what it means. Since we are only looking at the two columns, values and taxes, now each house is reduced to a pair of two numbers. For example, the first house, the value is 315, the taxes is A7, which is represented as a point in this system. So for example, let's blow up the graph a little bit, and then let's see if we can actually find this point in this graph. So the horizontal, the x-axis is 315, so it will be somewhere here, 315. The taxes is A7, so it will be somewhere here if you draw a horizontal lines here, and 315 here. The intersection should be a point. So if we move 315 up and then somewhere close to A7, okay, so this is actually the point that corresponds to these two numbers. So let me further blow up the scatter plot so we can take a closer look at the scatter plot between the value and taxes. So what does this scatter plot tells us about question 6? Do houses with higher value in this dimension pay higher taxes in this dimension? So for a house in this 300K value range, we see there's a wide range of taxes amount from somewhere here close to 3,000 to as high as almost 11,000. And for houses that pay 6,000 in taxes, you also have a wide range of values going from 200K to as high as about 550K. So this seems to suggest that the answer to our question 6, do houses with higher values pay higher taxes? The answer seems to be no. But what if we try to answer both question 5 and 6 together? We can look at the same scatter plot for each location. This can be done quickly by using filter. Click on the filter on the location and select all and only show location A, for example. So we see a complete different pattern. And similarly, you can go through location B, yet another different pattern, and location C. So there are quite a few things that you can observe by going through these scatter plot. So for the sake of time, I would just highlight 2. So let's go back to location A. As you can see here, there's a apparent upward trend where higher values of houses are associated with higher taxes. In other words, as values goes up towards the right, the taxes do go up towards the top as well. But there are other factors at play, because for these houses that are close to 400K in value, they are taxed quite differently. The second observation I want to share with you is if we look at location D, and then let's add to it the houses in location C. Then you can see the location D has a much higher tax rate than location C for the same value of houses. So the conclusion about question 5 and 6 seems to be yes to both. Namely, the taxes are calculated differently by location. And for some locations, for most of the locations, the higher value of houses are corresponding to higher taxes. But it's apparent that there are other factors involved in determining taxes beyond just location and value.